Morning, everybody. All right, so let's go ahead and get things started. So, let's start the conversation with why exactly should we really be concerned about changing to IPv6 in the first place. So, if any of you on the line are actually federal agencies, you have a mandate associated with this where all of the public-facing web portals have to be IPv6 compliant by the end of this year. Internal systems have to be capable and used for IPv6 data traffic by the end of 2014. Got the link there for that particular component. There was obviously some talk around the industry associated with having various enterprise-related accounts, not just governmental but commercial space, sort of tack onto this type of mandate and accelerate the adoption of IPv6 within the industry, but clearly that really hasn't happened based on the low adoption rate that we see. It is still something that companies need to be working toward because, obviously at some point in time, people will have cut over to IPv6. The dwindling IP space is creating problems where a number of new industries are connecting to the internet in that exact fashion. So eventually we have to be IPv6 simply to be able to maintain business. If we try to ignore the problem and depend upon other types of solutions to the dwindling IP space problem, we end up with problems like carrier-grade NAT, and then we run into monitoring problems as a result, where a single IP address presence from our perspective could be representative of thousands upon thousands of remote IP addresses, potentially full countries coming in through that particular IP because of carrier-grade NAT. So the other issue with IPv6 is that some of you probably are using IPv6 locally inadvertently, simply because of the fact that many operating systems come with IPv6 enabled by default these days. So there's local communications in a lot of cases moving around people's networks unbeknownst to the operator because they're simply being switched through the local platforms. So, what types of problems seem to be created for people whenever they're looking at the issues themselves, right? Why are people resistant to IPv6? I've heard a lot of issues around this. Some of those are that IPv6 is going to expose us to new and unknown threats, right? It'll be expensive to convert. I don't have enough time to plan for the upgrade, or the monitoring issue that gets introduced with IPv6 and existing tools, right? So with respect to exposing you to new threats, clearly we have new threats that we get exposed to every day, whether we're in an IPv6 or IPv4 type of environment. We need to start progressing into the IPv6 world and accept the fact that, yes, there are going to be some new vulnerabilities that are exposed, but the same is true of IPv4 networks as well. Risk avoidance is not a good reason to avoid IPv6 at this point. You simply need to plan for the security measures involved in protecting your network despite the fact that you're moving toward that particular upgrade. In terms of the expense, most of us have some type of refresh cycle associated with existing gear anyway. We're not asking anybody to go out there and just replace all of their gear tomorrow with IPv6 gear. What you want to do is plan for those upgrades. When you're naturally introducing upgrades to certain segments of the network, plan to introduce those upgrades in a way that can support running IPv6. And it's not like you have to convert the entirety of the infrastructure at one time, because dual stack networks are fairly common these days, right? So it's entirely possible for you to run both IPv4 and IPv6 stacks on segments of your devices, allowing you to maintain connectivity to both types of networks. In terms of planning avoidance, right? So this is definitely a concern for a lot of people, right? They're busy, they just don't have time to work out what's really needed. We can't avoid the problem, right? As I mentioned earlier, you can't just say, this isn't an issue for me, I'm going to avoid it. Eventually, you're going to come to a point where you have to adopt it, and avoidance now is going to create a time crunch later. And again, you don't have to have this change all at once. It can be small incremental change over the course of the infrastructure over a time period, but you do need to start planning for how that change is going to take place, what risks you're going to mitigate in which ways, and really start looking toward how this change can occur. With respect to the monitoring problem, I've heard this response a lot where people are saying, I don't know if my existing infrastructure can properly monitor IPv6. Most classes of monitoring tools these days have the capacity to be able to monitor IPv6. It's very likely that it's not going to solve all of the problems out of the gate. There's going to be changes to them as more and more adoption of IPv6 comes around, we'll understand that there are new problems that were generated, and those vendors will have to address it. But more than likely, your existing monitoring vendors have some type of IPv6 support. If they don't, there are definitely classes of systems within that same type of archetype that can do that for you. So make your vendors aware of the fact that you are aware of other vendors that support IPv6, and they need to add it so that you can continue support with their particular organization. So how exactly does NetFlow help out with the problem of IPv6, easing the transition with your infrastructure? What exactly is the value that it's going to bring to this interaction? So I'll caveat this at first with saying that when we talk about NetFlow, generically speaking, when we're talking about this problem with NetFlow-based technologies, we're referring to NetFlow version 9 or IPv6. A lot of people's networks that currently have NetFlow in use are using NetFlow version 5 if they have it turned on, simply because NetFlow version 5 has been around for a very long time period. But when we look at this format, there's some fairly clear problems with respect to IPv6, right? It's nearly impossible to shove an IPv6 address into 4 bytes of data, right? We're just missing a whole heck of a lot of bits, roughly 90. So you need to be using NetFlow version 9 or IPv6 because they have an extensible field format. You can tell them that you're monitoring your network using IPv4 or IPv6 or both in most instances, right? So here you're able to actually get access to the information to monitor and examine what's happening within the network segments. So what exactly does this start to look like? From the beginning, we can do very simple tasks with flow-based analytics against the data, right? You can track rate of adoption. Here we're looking at, it's kind of coming through a little bit small on my screen, but we're looking at the amount of data that's moving through our network over IPv4 from this perspective. And then we can simply overlay that type of data with IPv6 data, right? So here we can clearly see that we don't have nearly the amount of IPv6 adoption in-house that we have for IPv4 networks, but we can track the rate of change, right? As we start to trend this information, ideally we'll see an upswing in the amount of IPv6 data that's used within the network and a downturn in the total amount of IPv4, coming to where probably in a few years from now we can turn down the IPv4 segments within the network and be completely on IPv6 and not have to worry about running dual stack systems. Inventory reporting becomes fairly significant when we talk about IPv6 address as well, right? So for those of you that run vulnerability scans against your network for vulnerability management tools, which I'm going to assume is probably most of you if you're commercial grade businesses or particularly if you're in the government sector, when you start talking about doing things like vulnerability scan within IPv6 networks, it can become a little bit onerous, right? IPv6 has a very large amount of addresses on the whole, and when we talk about leading practices for ISPs, in general, they're providing /48 net masks to their customers. That's 80 bits of usable IP addressing space, right? Larger in theory than the total amount of space that's in use for IPv4. So unfiltered scans could take quite a long time to execute within the environment. How do we help offset that? Well, one of the benefits associated with flow-based analytics is that they can be deployed throughout the infrastructure, right? So rather than just looking at the type of data that's going on from an ingress-egress point to the network, we can see all the way down to end stations, and we can clearly identify what IP addresses have been in use within the recent time context, right? So what I would encourage from this perspective is that when you're running your vulnerability scans, take a look at your flow-based monitoring solutions. Say, what IPs have we seen today? Let's prioritize those toward the front of vulnerability scanning that we're conducting in the network, right? In a lot of instances, we won't be able to avoid not doing a complete scan of network resources and network ranges, but that's simply too much time to consume for the vulnerability scanner in terms of being able to create useful data. So prioritize up devices that have been known on the network ahead of devices that might be out there somewhere and turned on. You can also filter on this type of information when you're looking for it from a inventory management perspective to say, I'm looking for devices that terminate specific classes of services. I really want to identify within my IPv6 ranges devices that are used to terminate HTTP, HTTPS, FTP traffic, whatever it is that's interesting to that particular vulnerability that's being inspected within the network, right? So doing a quick classification ahead of time so that, again, you're reducing the scan segments. Being able to see the unseen has always been an issue with NetFlow, right? So it doesn't matter what type of monitoring tools you have. There's going to be threats within the network that manage to move through the cracks and make vulnerabilities within the infrastructure itself, right? The best tools will not be capable of detecting everything. We see that more and more with advanced persistent threat these days. When we talk about hacktivism or some of the lighter weight attacks, a lot of times we're talking about just exploiting common mechanisms. So those really are a matter of just filling in proper security gaps with mechanisms that can close those down. But targeted attacks or advanced attacks are ones that are going to circumvent the mechanisms because they're not using standardized attack vectors, right? Here, we can depend upon NetFlow to provide a forensic audit of what has gone on, right? So even if we weren't able to detect it, either with flow-based analytics or with traditional security measures, NetFlow data is going to tell us about how those transactions moved around through the network, what resources they accessed, how long they were there for. It's our audit trail of what has happened. Right? Now, as we start to take these types of analytics against the flow data, whether it's IPv4 or IPv6, Landcope as a company does some fairly interesting things with the IP transactions themselves. Rather than looking at signature-based detection for alerts, we're doing flow-based anomaly detection to look for patterns of data, to look for behaviorally atypical information. So here we can see, via an IPv4 segment, how we're looking at the transactions. The same thing would be true for IPv6, right? Scanning is probably going to be a bit less prevalent within IPv6 networks as a method of finding intrusion, but this is just a simple example of what we're looking at for different types of actions, right? So you're looking at root behaviors of how hosts are communicating with each other, building in and understanding what those patterns look like for individual devices within the network. As you start to understand that type of behavior, now we can trend on that information and alert against atypical types of behaviors that go around through the network, classified by types of systems or by individual machines within those particular sectors. So in this instance, we're looking at a high traffic incident from an Exchange server potentially, or it could be an atypically large number of sends being received by the device. So it might be that it's being targeted by a denial of service. Perhaps one of our Exchange servers actually got compromised, though, and rather than doing a high number of targeted attacks toward it, he could be initiating a particular type of attack. So maximum numbers of simultaneous sessions that are moving through the host, or maybe he's doing an atypical amount of scanning, extraordinarily large amounts of data moving into and out of it, but it's fairly easy to understand that type of data from flow characteristics once we have visibility into the entirety of the infrastructure itself. So these are the types of things that we're talking about being able to disclose using flow-based analytics. So what we've got is a mix of being able to understand rate of change within the networks. We've got the ability to do proper inventory management within our infrastructure and identify what resources are using IPv6 and for what purpose. We can take that information and behaviorally trend it. We can prioritize, and we can look at different types of threats based upon behavioral differences in the way that those systems interact. And again, the benefit here is that because we're doing it against root behaviors for those systems, it really doesn't matter if the system is IPv4 or IPv6, right? Root behaviors are root behaviors for those systems no matter what. When we start to apply these into particular types of containers, some of the most common ways that we can leverage flow-based analytics for security use cases, we can look for the advanced persistent threat type data. And what we're really looking for here in general is going to be root behaviors that the advanced persistent threat might take, right? So looking for data reconnaissance moving around within the network, right? Even low and slow type of mechanisms that may not move across our perimeter defenses for an extended period of time. We're looking for potential spread of malware within the infrastructure, right? Somebody clicks on an email link that they shouldn't have clicked on, or they go out to a website that they shouldn't have gotten to, and then that causes some type of propagation within the infrastructure. We're looking for the command and control or remotely controlled machines within the network, right? So this could be based off of connections to known bad lists, or in the case of advanced persistent threat, more often than not, we're detecting those through covert channel detection, through mechanisms that are looking at flow characteristics that are indicative of that type of communication, extraordinarily long-lived communications to external hosts, or beaconing activity typically identify this type of metric to stealth watch. And then finally, we can look for things like data loss within the infrastructure. People moving large amounts of data from inside of the network to outside of the network that's outside of the profile for those individual machines. Now, certainly, we wouldn't want to flag whenever the marketing department uploads large amounts of collateral to external data sources, but it is very interesting whenever somebody from our finance department, for instance, uploads large amounts of data to, Russia or Korea or someplace that we would consider to be threatening as an industry because we don't do a great deal of business in those particular regions. So these are the types of things that we can identify using NetFlow for security mechanisms in the IPv6 world. So we can really cover a fairly broad swath of types of criteria within IPv6